Hello listeners and viewers, welcome to Kaduna State Ministry of Education Radio and TV e-learning program designed for our SS3 and other students staying at home due to the coronavirus pandemic. The present administration under the able leadership of His Excellency, Malam Nasir Ahmed El-Rufai, is positioned as always to ensure that under his leadership, our students are not left behind in all areas of human endeavors, especially education. Kaduna State is the center of learning. Therefore, we want to ensure that our students excel in their forthcoming examinations and beyond. Students and other learners at home are given this opportunity in order to continue learning, as education is a continuous process. Different subjects will be taught in this program to assist students to perform excellently in the forthcoming Senior School Certificate examination being conducted by NECO and WAEC as soon as schools reopen. Teachers making presentations will always provide their names and phone numbers during each presentation, and they can be contacted for questions, further explanations, and/or clarifications. The following numbers and contacts can also be reached for expression of any concern or observation: 090-865-00545 or 080-383-62072. Our website is www.education.kdsg.gov.ng. Our email education@kdsg.gov.ng or education.kdsg@gmail.com. Our YouTube channel, Ministry of Education, Kaduna State. Our Twitter handle @Kaduna_MOE. Or our Facebook page, Ministry of Education, Kaduna State. Stay safe, stay at home, and learn well. Thank you, happy listening, and happy viewing.
Good day, listeners and viewers. You are welcome to yet another segment of our e-learning under the subject Mathematics. I remain Bakwai Monday. I'm going to take us through polygons and under the subtopic classification of polygons. Now, polygon can be classified in the following ways. Polygons can be classified in the following ways. 1. Convex polygon. Convex polygon. And what is a convex polygon? A convex polygon is a polygon with each of its interior angle less than 180 degrees. Each of its interior angle is less than 180 degrees. Then we have 2 reentrant polygon. Reentrant polygon. What is reentrant polygon? A reentrant polygon is a polygon with one or more of its interior angle greater than 180 degrees. One or more of its interior angles greater than 180 degrees. We move to equilateral polygon. Equilateral polygon is a polygon with all its sides equal to each other. Equilateral polygon is a polygon with all its sides equal to each other. Then we have equiangular polygon. Equiangular polygon. An equiangular polygon is a polygon with all its angles equal to each other. An equiangular polygon is a polygon with all its angles equals to each other. And then 5, we have regular polygon. Regular polygon. A regular polygon is a polygon with all its sides equal and all its angles also equal to each other. All its sides equal to each other and all the angles are also equal to each other. Now we are going to particularly consider a regular polygon in all the classification above. We are going to consider regular polygon in all the classification above. As from the definition, a regular polygon is a polygon with all its sides and angles equal to each other's. Now, the size of each of a regular polygon can be determined using the formula. Each angle equals the sum of the interior angles divided by the number of sides. Each of its interior angle can be determined using the formula. Each angle equals to sum of its interior angle divided by the number of sides of the polygon. Therefore, for an n-sided polygon, the sum of each of its angle is equivalent to n minus 2 in bracket multiplied by 180 degrees all divided by n. Each of its angle will be n minus 2 multiplied by 180 divided by n, which is the number of sides. Now, we are going to cite examples to be able to justify the definitions we have stated above. Examples. Number 1, we are expected to calculate the size of each angle of a regular dodecagon. Calculate the size of each angle of a regular dodecagon. That is question 1. While question 2 says each angle of a regular polygon is 108 degrees. Each angle of a regular polygon is 108 degrees. How many sides has the polygon? How many sides has the polygon? Suggest a name for the polygon. Suggest a name for the polygon. The question again, each angle of a regular polygon is 108 degrees. Then how many sides has a polygon? And then suggest a name for the polygon. Question number 3, one angle of an octagon is 65 degrees. One angle of an octagon is 65 degrees. The other angles are regular. The other angles are regular. Find the size of each of the regular angles. Find the size of each of the regular angles. Example 4. What is the ninth term, or what is the ninth angle of a nonagon if the angles are 124 degrees each? What is the ninth angle of a regular of a nonagon if the angles are 124 degrees each? Then we have our solution as follows. Solution to question number 1 in the example. We need to know what a dodecagon is. And a dodecagon is any polygon bounded by 12 sides. Any polygon bounded by 12 sides is named as a dodecagon. Therefore, in this case, our n is 12. Our n is 12. Then we first find the sum of the interior angles. And the formula for finding the sum of the interior angles, as we are aware, is given by n minus 2 all in bracket multiplied by 180 degrees. N minus 2 all in bracket multiplied by 180 degrees. Now we have already known the value of n, which is 12, as dodecagon. Now each angle will be equals to n minus 2 in bracket multiplied by 180 divided by n. Now since our n is 12, we now substitute. As we substitute our variable, the number of sides is 12, so we have 12 minus 2 multiplied by 180 degrees. 12 minus 2 multiplied by 180 degrees, all divided by 12, which is n. And by mathematical simplification, 12 minus 2 is 10. 12 minus 2 is 10. Then 10 multiplying 180 degrees, all divided by 12. If you do the multiplication correctly, you will have 1,800 degrees divided by 12. 1,800 degrees divided by 12. And if you divide that by 12, 1,880 degrees, 1,800 degrees divided by 12, you will be having 150 degrees. 150 degrees. Hence, each of the angle is 150 degrees. That is the solution to number 1. Then let's move to number 2. From the question, it is clearly spelled out that each angle of the polygon is 108 degrees. Each angle of the polygon is 108 degrees. Now you state the formula for each angle, which is n minus 2 times 180 divided by n. N minus 2 divided by 180. N minus 2 times 180 divided by n. And each of the angle is 108 degrees. So if you make your substitution appropriately, you have 108 degrees equals to n minus 2 times 180 degrees. Then if we move further, you will have 108 multiplied by n, you have 108n. Then expanding the numerator in the given fraction, we have 180 times n is 180n, and then 180 multiplied by 2 is 360 degrees. Then rearranging by collection of like terms, we will have 360, which is negative, coming to the other side become positive. So we have 360 degrees equals to 180n minus 108n. 180n minus 108n. If you subtract that properly, 180n minus 108n, you will have 72n. You will have 72n. So dividing through by the coefficient of the unknown. Our unknown here in this case is n, which is the number of sides we are looking for. So 108 subtracted from 180 has given us 72. When you divide through by 72, you have our n, 360 divided by 72 to be 5. 360 degrees divided by 72, the result is 5. It means our n in this case is 5. Hence, the polygon has 5 sides. Hence, the polygon has 5 sides. And any polygon bounded by 5 sides is a pentagon. So the name for the polygon is a pentagon, because we are also suggest a name for the polygon because it is 5-sided. It is a pentagon. Now, example 3 in our question, we are given an octagon, which is any polygon bounded with 5 sides. An octagon is any polygon bounded with 8 sides. And then one of its angle is 65 degrees. One of its angle is 65 degrees. The other angles are regular. It means they are equal to each other's. And if you have 8 sides and one angle is given, you will now be left with 7 angles, because 8 angle minus 1 of the angle given, you will be left with 7 angles. And all these 7 angles are equal to each other because they are regular. Regular means they are equal to each other. Therefore, we represent each of the regular angles as x. So, from the sum of the interior angles of a polygon, n minus 2 times 180, you replace the value of n with your 8 because octagon is 8 side. Octagon is 8 side. So I'll be having 8 minus 2 times 180 degrees. 8 minus 2 times 180 degrees. By your mathematical simplification, 8 minus 2 is 6. 8 minus 2 is 6. So we'll be having 6 times 180 degrees. 6 times 180 degrees. And if you multiply 6 by 180 degrees, you will be having 1080 degrees. That is the sum of the interior angles of the octagon. Now, it means therefore, if you sum up all the angles, the first angle was given as 65 degrees, and we have represented each of the regular angles as x. So we'll be having x, 65 plus x, plus x, plus x, plus x, x in 7 places. X in 7 places. You will now have 65 degrees plus 7x. 65 degrees plus 7x, all equals to 1080 degrees. 1080 degrees. Now, by collection of like terms, we have 7x equals to 1080 minus 65 degrees. 1080 minus 65 degrees. Simplify that, 1015 degrees. If you subtract 65 from 1080, you will be left with 1015 degrees. Now, how do we determine the value of x? We divide through by the coefficient of the unknown. And the unknown is x. The coefficient of x is 7. So when you divide through by 7, which is the coefficient of the unknown, you will be left with x alone. And then you have 1015 degrees divided by 7. 1015 degrees divided by 7. If you do that correctly, you will be having 145 degrees. S will be 145 degrees. Because 7 in 10, you have 1, you are left with 3, it becomes 31. Into 31, you have 4. You are left with 1 into 15, you have into 35, you have 5. So 1015 divided by 7, you have 145 degrees. So each of the regular angles of the octagon is now 145 degrees. Each of the angle of the regular angle of the octagon is 145 degrees. Example 4. We need to know that a nonagon is any polygon bounded by 9 sides. A nonagon, because the question mentioned nonagon, you must understand the word nonagon, a figure bounded by 9 sides. Therefore, we need to find the sum of its interior angles using the general formula, which is n minus 2 in bracket times 180 degrees. N minus 2 in bracket times 180 degrees. Now our n is 9. We replace the value of n by 9 accordingly. So we'll be having 9 minus 2 multiplying 180 degrees. And 9 minus 2 is 7. 9 minus 2 is 7. So 7 multiplied by 180 degrees. 7 multiplied by 180 degrees will give us 1260 degrees. 1260 degrees. Now, let the ninth angle of the polygon be x. Let the ninth angle of the polygon be x. The remaining angles are each 124. The remaining angles are each 124 degrees. That is the instruction given from the question. So it means out of 9 angles, you have 8 angles that each of them is 124. So we must now form the equation as s plus 8 multiplying 124 degrees. 8 multiplying 124 degrees. If you do that correct, you'll be having s plus 8 times 124 degrees will give you 992 degrees. 992 degrees by collection of like terms. We collect like terms. X will give me equals to 1260 degrees, 1260 degrees minus 992 by collection of like term. Positive term become negative. If it were negative, it will become positive, and vice versa. So when we transfer 992 to the other side, it becomes minus 992. Making the simplification, my x in this case will be 268 degrees. 268 degrees. Therefore, the ninth angle of the polygon, the ninth angle of the polygon will be equal to 268 degrees. The ninth angle of the polygon will be 268 degrees. That is the value of the ninth angle. Each other angle is 124, but the ninth angle that makes the nonagon will be 268 degrees. All right, my dear student, before we conclude the lesson, I will need to give you an assignment. You have an assignment to practice at home, and you can send in through WhatsApp page for us to correct you where necessary. Question 1, calculate the size of each angle of a regular hexagon. Calculate the size of each angle of a regular hexagon. In our previous topic, you must know what is a hexagon, and you should take note. Question 2, each angle of a regular polygon is 144 degrees. Each angle of a regular polygon is 144 degrees. How many sides has the polygon? How many sides has the polygon? Suggest a name for the polygon. Suggest a name for the polygon. The last question, question 3. One angle of a pentagon is 124 degrees. One angle of a pentagon is 124 degrees. The other angles are regular. The other angles are regular. Find the size of each of the regular angles. Find the size of each of the regular angles. Our reference material, you have New General Mathematics for Senior Secondary School Book 3, New General Mathematics for Senior Secondary School Book 3. Then we have Comprehensive Mathematics for Senior Secondary School. Comprehensive Mathematics for Senior Secondary School. We equally have Essential Mathematics for Senior Secondary School. Essential Mathematics for Senior Secondary School. Finally, question and answers, Q&A, popularly known by students for mathematics. Question and answer, Q&A. These are our reference material. I remain Mr. Monday Bokwe. You can always get me through my phone number 080-2525-9755. 080-2525-9755. Stay home, stay safe, keep learning, and God bless you.